right, hi Alina. I figured I'd help you with the lab by just recording some things. This is going to be question number 2, and I'll break it down into different questions. So, first things first, you have to go to the Rotating Sky Explorer lab, and it says for question number 2 to add a star, and we're going to just add a star randomly, and you can see it just places it randomly on here. It's going to be in a different position. I can drag the star wherever I want it, or we can just set the azimuth and altitude right there. So just click on it. Click on the azimuth, type in 0 for star A and 20 for its altitude, and that will set the star right above the horizon in the north. Okay, remember azimuth of 0 is north. Now, what we need to do is we need to look for the NCP, that's the North Celestial Pole, because that's kind of critical for our diagram, because in the question it says to draw in the location of the North Celestial Pole. And if you think about this, this person is at a latitude of evenly 40, okay? Which means the angle of the NCP is 40 degrees from here to here, okay? If I were to drag my star there, you can actually see that the altitude of the NCP is 40 degrees, or close to that, okay? So I'm going to put this at 20 degrees, and I'm putting this at 0. Okay, so I have my altitude and azimuth of star A set there at 20. Now, let's go to the actual diagram, and we're going to draw a few things. So first off, we need to draw where the NCP, or the North Celestial Pole, is located. And North Celestial Pole is located in the north, right? So it's along this line, and it's at an altitude of exactly 40 degrees because that's my latitude. Now look at these lines. This is the 10 line, so 10 degrees. This is the horizon, that's 0. 10 degrees, 20 degrees, 30 degrees, and 40 degrees altitude is right there. So that dot right there is the NCP. Okay? Now, everything is going to go around the North Celestial Pole, Polaris, and all of the stars that you put on here are going to go around this. And that's our next part. We're going to simulate that, and we're going to do that with star A. Now, the first thing that we have to do is we have to draw star A on this diagram. And you said that, or we said that it was an altitude of 20, azimuth of 0. Azimuth of 0 is right here, right? North. So I'm going to draw it on this line at an altitude of 20. That would be right there. So star A is there, and we'll just say that this is time equals 0. Okay? So that's the first part. Now, the next thing after that is we have to kind of see what happens to the star as it goes around the sky. So I'm going back to my Sky Explorer, and I'm going to set my animation, as it says in the question, number 2B, set the time for 6 hours. Okay, so 6 hours. And now what we're going to see happen is this star, I'm looking at it from this guy's perspective, is going to go around the NCP there in the background. And I want to watch that happen, so I'm going to start the animation. So here we go, 6 hours. Okay, and you can kind of see it's going counterclockwise around the circle, and then it stops right there. Now, notice it tells me what the altitude and azimuth are. So we're going to write that down in our coordinates in our lab. I'll go back to the lab. Okay, so right here, that's where you're going to put those coordinates that you saw on the screen. So right there, 37.2 for the altitude, 25.4 for the azimuth. Okay, and that's in the eastern sky in the north. Okay, northeastern sky. So what I'm going to do is we're going to go back to this. We're going to take a look at our diagram, and we're going to draw that dot in there after 6 hours. So if you look, the altitude is 37.2. So we need to find, there's 10, there's 20, there's 30, there's 40. So it's somewhere in this range. And the azimuth is 25.4. At least I believe that's what it said. Yep, 25.4. And so we have to find 25.4. Here's 10, here's 20, and that means 25.4 is right here. So we're going right around here, approximately, and that's A after time equals 6 hours, okay? And so we drew an A, and we're going to connect that. We're just going to draw an arrow like that, okay? Next, what you're going to do is you're going to come back to this, and you're going to do it for a time of 12 hours. So that would be an additional 6. So again, start the animation, watch this go around, and it's going to go around counterclockwise from his perspective, and it's going to end up way up there like that. And again, you're going to write down the coordinates, and then you're going to draw that onto your diagram right here, okay? And then you'll do it one more time for another 12 hours this time, because you want to go all the way back to where you started. So you set it for 12 hours, start the animation, watch it go, and then redraw in that in their fisheye diagram. And the star will end up, as you can see, back where it started. So after 24 hours, a star will go all the way around Polaris, and it will come back to where it started. Okay, so that's the first part, and you're drawing that onto your diagram here. Okay, and so what you'll get is a big circle going around the NCP. All right, the next one, draw in star B at the specified locations, coordinates, and this is times 0. So we're going to put another star in here. And in fact, I'm just going to use this star. I'm going to change it to make it star B. And it says that the azimuth is 90 and the altitude is 0. Okay, and you'll see that that ends up being right on the horizon right here, on the eastern horizon. So let's go to our fisheye diagram, and we're going to draw that. Now, azimuth of 90 is right here on the eastern horizon, and 0, so we're going to put that right there. That's star B. Okay, and what we want to do is we want to draw what happens to this star after, as it says, 3 hours. This is time 0, time equals 0. And we got to do 3 hours on our clock here. So we're going to change this to 3 hours, start the animation, and see what happens to that star. You can see it's rising, and then after 3 hours, it's risen to that altitude and azimuth. And you can write those numbers down right on your lab. Okay, and you can put that, by the way, right here on the bottom. Put those numbers in, and then we're going to draw where that is on our diagram right here. So if we draw that correctly, the azimuth was 122.7. So that's going to be like right around here somewhere along this line. And the altitude is 32.8. So here's 122.7 approximately. And 32.8, that's 10, 20, 30. It's like right here. Okay, so this is star B after time equals 3 hours. And we're just going to connect the dots there by drawing an arrow. That'll be star B. Okay, and then you'll do the same thing as it says in the lab after 6 hours. So it says up at the top 6 hours. So do another 3, and then do another 6 after that for 12 hours. And again, you're going to draw that onto your diagram, draw an arrow. Okay, and what you'll get is a path that goes all the way across the sky and actually sets over here in the west. So that's star B. And then you'll do the same thing for star C. Now for star C, what I'd like you to do is just cross this out, okay, and this out, and this out. And what I want you to realize is star C, as it says in your lab, is at an altitude of -5, so -5, and an azimuth of 180. So as you can see, it's actually below the horizon. And if I animate this for, let's say, 12 hours, watch what happens. Actually, we'll do it for continuous. Watch what happens. Does it ever rise? It never, ever comes up above the horizon. It stays there below the horizon. It's never visible for this guy at 40 degrees north. And therefore, basically, when you do this part of the lab, it never shows up. It's never there. And therefore, I never really want you to draw it on the diagram. It started like right here. Okay, that's star C, and it never comes up. It goes down here somewhere. Okay, so you can ignore all these, and you can say basically what fraction of the day is the star visible? None. It's never visible. Never comes up. Okay, so that's question number 2. And if you have any questions about question number 2, just let me know.